So in this example, I would like to do a problem involving an orifice flow example. And what I have is I have two different scenarios. I have one scenario here where I'm going to have a free flow scenario, and the other scenario involves a submerged flow. Now, the orifice that we're talking about is actually a 2 foot by 4 foot orifice. It's square, as you can see, or rectangular, and it's got a coefficient of discharge of 0.6. So let's start over here with the scenario 1, free flow scenario. Okay. So what we have is we have a pond right here, okay, where the water surface elevation is 230 feet. Okay. The ground elevation is 203, and the orifice, which again, the 2 foot by 4 foot wide orifice, is located at an invert elevation of 211. What I mean by invert elevation is that's the elevation of the bottom of the orifice. Okay. So the orifice is, again, it's going to be 2 feet tall. 4 feet would be going into the board. And what I want to know in each case is what's the flow. So what is the flow under this free flow scenario? Okay, so the formula that we're looking at for this is just going to be the coefficient of discharge times the area of the orifice times the square root of 2g and then this h1 value. Now, h1 is actually defined as the distance. If you go back through in the derivation of this equation that's posted online, in which we used energy equations from point 1 to 2, and we come up with the Torricelli theorem, that's essentially what this is here. h1 is defined as the distance from the center line of the orifice to the water surface, okay? So in our case, that distance h1 is the 230 feet, okay, minus, and the elevation at this point here, if the orifice is 2 feet tall, to the center line of that orifice would be another foot, so that elevation would be 212. Okay, so our h1 is 18 feet. Now, one thing I should mention with this free flow scenario, because the water is free to exit this orifice, there's nothing downstream hindering or restricting the amount of flow that's coming out of that orifice. So this is what we call an upstream control. I'm going to be talking a lot about that later on in the course with different hydraulic structures. So it's better that we just go ahead and get that terminology taken care of now, all right? So again, we have upstream control in that the elevation upstream, in this case in the pond, is what's controlling that flow. All right, so moving on with the equation, we get flow is equal to, we have a coefficient of discharge of 0.6. The area of the orifice, it's a 4 foot by 2 foot orifice, rectangular orifice. And again, we're going to have the square root of 2. G in English units is 32.2 feet per second squared. And then we have our 18 feet right here. Let me extend this over. Okay. And this gives us a final flow of about 163.4 cubic feet per second. Okay. So under the free flow scenario, in which everything's being controlled upstream, there's nothing downstream hindering its flow, we expect about 163 CFS. Now let's take the same orifice, the same 2 by 4 orifice, but let's put it in a scenario in which we have a submerged flow. Okay? So with the submerged flow, rather than have an upstream control, we have a downstream control. Okay? And what we're saying with the downstream control is because the water elevation here is actually above the orifice, okay, in this case, the water on the right-hand side is actually controlling how much water can pass through on the left, all right? So it's a downstream control. Now, we have a similar equation for this. The equation that we use actually has the coefficient of discharge, A naught. It's got 2G as well. The only difference now is it's actually looking for the elevation change between this water surface and this water surface, but the way it's defined in the derivation is they're going to use these heights H1 and H2. Okay? So in this case, H1 is, again, it's going to be the 230 minus the 203, which gives us 27 feet. H2 is going to be the water surface elevation of 218 minus the 203, which is 15 feet. And so all we're going to do right now is just insert those terms into the equation. Okay, we've got a 4 foot by 2 foot orifice, 2 times 32.2 feet per second squared. And then the height difference here is the 27 minus the 15, okay, which would be just 12 feet. Again, visually, if you want a shortcut for this, again, it's just essentially it's going to be this distance here is the shortcut. You're just looking for the elevation between one water surface and the other, which would be 230 minus 218, okay, or 12 feet. And when we calculate the flow with this rating equation, we get about 133.4 CFS. Okay. So when it was a downstream control, we had 133. When it was an upstream control, we had about 163. And again, with the same scenario in terms of the same water elevation for the pond, the difference just being what's going on downstream. And this is roughly about a 20% difference. And that concludes our example of an orifice flow scenario.